Hello everyone, and welcome to my very first YouTube video on my new channel Science Done Right. And I'd like to basically create a playlist to help all the students out there that are struggling with organic chemistry. And for the very first video, I'd like to begin with kind of a review about what topics from general chemistry that you should recall and remember before we actually dive deep into organic chemistry and the rigorous mechanisms and nomenclature and other kind of fun stuff. So basically, before I start any of that, however, I'd like to begin with basically just creating a definition of what organic chemistry is and some of its practical uses in everyday life. Now, of course, there are going to be more rigorous and detailed definitions if you go online to Wikipedia or something, but what I'd like to do is just give a basic definition of what I think organic chemistry is and go from there. So, organic chemistry, what is it? Well, organic chemistry is just a branch of chemistry that deals with organic compounds. Now you might be wondering, what exactly is an organic compound? An organic compound is anything that's derived from a living organism such as plants and algae. So that's what I believe to be a simple and precise definition of what organic chemistry is. And some practical uses of organic chemistry. Well, organic chemistry is something that's actually seen all the time. You're directly affected by it every single day because organic compounds are always in foods we eat, the clothes we buy, pesticides, pharmaceutical drugs, and heck, even in our own DNA and our bodies, which are composed of many organic compounds. If you've had a good experience in biology, then you would know some common and good examples of organic compounds found in our bodies. So now that we have essentially a good basic definition of what organic chemistry is and some practical uses to kind of give an idea of why we use it so much and why it's important, I think I want to go more into something that we've generally kind of reviewed in a general chemistry course. Now, I want to stress this enough. I'm not going to go into the very, very, very rigorous details of the topics that we're going to review from general chemistry because that's not what I want to do. All I want you guys to know is a basic understanding of some of the topics we cover in general chemistry and then go from there. So basically, I'd like to begin my review of general chemistry with something called the structural theory of matter. Now, the structural theory of matter, what the key importance that I want to really talk about is something called these definitions up here. So tetravalent, trivalent, divalent, monovalent, what that is, what it means, and then something called constitutional isomers. So before we start, I'd like to talk about what these words up here mean and these kind of pictures that I've drawn. So basically, the structural theory of matter kind of describes how many bonds that elements can form. Now, you've probably heard the common saying carbon likes to have 4 bonds. And essentially, that's exactly what tetravalent means, having 4 bonds. And these kind of dashes I have here are just represented by bonds. They could be bound to anything. This could be a hydrogen, this could be a halogen, anything. And then we have trivalent, divalent, monovalent. So trivalent with 3 bonds, divalent with 2 bonds, and then monovalent with just 1 bond. Kind of like our prefixes mono, di, tri, tetra. It's a good way of remembering it. And the second thing I'd like to talk about in the structural theory of matter is something called constitutional isomers. Now, constitutional isomers are basically compounds that have the same molecular formula, but they differ in the way that the atoms are arranged. So a prime example of that is something right here. I have a dimethyl ether, so I have 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen. And then I have something called ethanol here. The exact same thing. I have 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen. Now, don't worry too much about the name, how this is a dimethyl ether and how this is an ethanol. We're going to get more into nomenclature and how to recognize functional groups and stuff like that in the future. But for now, all I want to focus on is how constitutional isomers are basically 2 compounds that have the exact same molecular formula, but it's just the arrangement of atoms are different. Well, as we can see here, we do have the exact same molecular formula, C2H6O, C2H6O. But the key difference here is that in the dimethyl ether, I have a carbon attached to an oxygen attached to a carbon. But when I look at our ethanol, I have two carbons that are directly attached to each other and then the oxygen on the side. So I have this right here and then this. And you might have noticed why I have the boiling points written for each of them. So the boiling point of the dimethyl ether, negative 23 degrees Celsius. The boiling point of our ethanol is 78.4 degrees Celsius. And the reason I wrote that down is because the key thing that I want you guys to understand, besides understanding the definition of a constitutional isotope, is that they have different properties. Yes, they may have the same molecular formula, but that arrangement of atoms changes the physical properties of the compounds. And as we can see, a prime example of that is a boiling point. How if I have the dimethyl ether, my boiling point is negative 23, but once I rearrange this with the same molecular formula still to make ethanol, the boiling point skyrockets. And an explanation as to why, we're going to talk more about that once we kind of start talking about alcohols and ethers and stuff like that, and why an alcohol would have such a high boiling point compared to an ether. We're going to get all into that once we get further on into organic chemistry. So those are the two kind of key things I wanted to talk about for the structural theory of matter. Now, I want to end this video off with something called bonds. And what are they? Well, everyone really knows what a bond is. It's kind of like something glued together. You could think of it that way, like two atoms glued together. But before I actually talk about the bond itself, I want to talk about a brief history of electrons. So basically, we have the existence of the electron, and this E negative is kind of my way of subscripting an electron to kind of save myself some room instead of writing electron out. Well, that's how I'm used to it. So the existence of the electron was first proposed by George Johnstone Stoney. He attempted to explain electrochemistry, which is another branch of chemistry, by suggesting that a particle with a charge exists, and this particle with a charge that exists, he dubbed the name electron. Now, as we all know, J.J. Thomson is the one who discovered the electron, and he basically proved that it existed. So he was the one who got the award for it. And another thing I want to talk about is a person named Gilbert Lewis. And basically what he did was he used these electrons that J.J. Thomson discovered to describe a covalent bond. A covalent bond is very important. So that's why I want to start off with a covalent bond. A covalent bond is when two atoms share a pair of electrons. So for example, I have this H, and this dash represents a bond, as we talked about before, to an H. So this is a pair of electrons. And essentially this is what it is. These dots here represent an electron. One electron from the hydrogen, one from the other hydrogen, and they kind of share them. So that's what a covalent bond is. Now, there's many other types of bonds, like ionic bonds, polar covalent bonds, stuff like that, which we're going to talk about in future videos, probably my next video, where I'm going to go a little bit more into the details of other topics of general chemistry that we should understand before we talk about organic chemistry. And I'm also going to do a lot more examples. This video is kind of just an introductory sequence to what organic chemistry is and stuff like that, and kind of just get some basic theoretical review done. Nothing too rigorous. So the last thing I want to talk about today is the review of the atomic structure. Now, this is something that you've probably been introduced to in high school, but I just want to kind of re-talk about it for simplicity's sake and better understanding. So we know that an atom is composed of a nucleus. The nucleus is what has the neutrons and protons. And basically the electrons are in the outer shells, and each shell basically holds a specific number of electrons. So for example, the first shell holds 2, and then the second shell holds 8, and therefore, etc., etc., etc. And one thing that I didn't write down that I want you guys to know is the electrons in the very most outer shell of an atom are called valence electrons. So once again, valence electrons are electrons that are in the outermost shell. Now, why we talked about all of this is basically because Gilbert Lewis basically invented a way of showing, or he basically created his own structure, which he dubbed Lewis structures, which kind of show how electrons kind of bond with one another in molecules. So for example, in carbon dioxide, he kind of showed how basically the oxygens and the carbons and how all their electrons kind of are bonded together and stuff, and he basically dubbed that a Lewis structure. Now, I'm going to save that for the next video, where we're going to talk about a Lewis structure in detail, some common rules for Lewis structures, how to draw them, and then from there I want to kind of get into the different types of bonds there are, such as ionic bonds, polar covalent bonds, as I talked about before, and then furthermore, I'm going to get into hybridization and all that kind of stuff, and wrap up the general chemistry review. And after that, once all that is covered, we're going to dive into what organic chemistry is. So for now, that's where I'm going to stop it today. I hope you enjoyed my video, and I'm really hoping that you guys will give me some good feedback. I'll have my email in the description below. If you ever have any questions, concerns, comments, shoot me an email or just comment below, and I'll try to do my best to respond to you guys, and give me some ideas of what else I should talk about. If I didn't clarify something properly, tell me, criticize me, all that kind of stuff. And basically, I hope that kind of helped you guys learn what organic chemistry is and kind of get an introduction to what organic chemistry is. And yeah, that's it for now, and I hope you guys will keep on supporting me through, and I hope that I'll keep getting more demand to do more of these videos, and any other topics that you want to see covered. Even if you want to do for me to do some general chemistry topics and stuff like that, I'll be more than glad to. But I guess that's it for now.